Hydrothermal activity has resumed in the Biscuit Basin area of Yellowstone National Park. In less than 24 hours, 2 hydrothermal explosions rocked the area, causing the ground to crack, collapse, and form new hot springs that continue to exhibit geyser-like activity. According to the Yellowstone Volcano Observatory, one of the explosions threw rocks into the air and created numerous cracks in the ground surface. The largest crack was more than 18 meters, about 60 feet long. Several days after the explosion, the weakened ground finally collapsed, forming a new hot spring, measuring approximately 6.4 meters by 5.2 meters, 21 feet by 17 feet. The spring is now actively boiling and occasionally shoots hot water 6 to 9 meters, 20-30 feet, indicating that the hydrothermal system beneath the surface remains highly dynamic. No tourists were present at the time of the explosion, and therefore no injuries were reported. Previously, a hydrothermal explosion on the 23rd of July 2024 shocked the world after it sent a plume of mud, rock, and steam nearly 60 meters, 200 feet into the air. Tourists on the hiking trail fled for their lives, and the national park subsequently closed the Biscuit Basin area for safety reasons. Michael Pollan, the scientist in charge of the Yellowstone Volcano Observatory, explained that the explosion was not caused by magma moving toward the surface, but rather by changes in pressure within a shallow hydrothermal system. Underneath Biscuit Basin lies a network of channels filled with superheated water. This water continues to boil as it is heated by hot rocks deep beneath the surface. Over time, minerals carried by the water can clog these channels. When the pressure builds and is suddenly released, the superheated water instantly turns to steam within seconds. This sudden change from water to steam is what produces a powerful explosion capable of throwing rocks into the air, opening new vents, cracking the ground, causing the ground to sink, and forming new hot spring pools. Why does Biscuit Basin erupt so often? Hydrothermal eruptions are actually quite common in Yellowstone and likely occur several times each year. However, most occur in remote locations, never witnessed by humans. However, Biscuit Basin appears to experience eruptions more frequently than other geyser areas. Scientists still don't know the exact cause. One hypothesis is that the temperature of the groundwater in this area is so high that even the slightest change in pressure can trigger the water to explosively turn into steam. Although there were 2 explosions in a short period of time, scientists emphasize that the impact was limited to the immediate area around the explosion site. This is not a sign that Yellowstone is about to erupt. Claims have surfaced on social media that Yellowstone is becoming more active and is on the verge of a major eruption. However, scientists emphasize that this is not true. According to Michael Pollan, these events are simply part of the normal behavior of Yellowstone's hydrothermal system. It's simply Yellowstone doing what it always does. This is how the hydrothermal system in this national park works. The difference is that we now have far more sophisticated technology that can detect events that were previously virtually unobservable. In other words, a hydrothermal explosion like this does not indicate that the Yellowstone supervolcano is preparing to erupt. One of the most significant aspects of this event is that scientists were able to record the explosion live using a new network of monitoring equipment installed in Biscuit Basin after the 2024 eruption. This equipment includes high-resolution monitoring cameras, seismometers to record ground vibrations, GPS stations to measure changes in the ground surface, infrasound sensors capable of detecting very low-frequency sound waves from hydrothermal activity. When the explosion occurred, the entire system automatically sent an alarm to scientists. Cameras pointed directly at the site also recorded the steam plume from the beginning of the event. The collected data captured not only the moment of the explosion, but also the hydrothermal activity from several days prior. Researchers now have the most comprehensive dataset ever obtained from a hydrothermal explosion at Yellowstone. Michael Pollan said the primary goal of this research is to identify early signs, or precursors, that appear before an eruption. If these patterns are identified, scientists hope they can one day provide early warnings, allowing hazardous areas to be closed before an eruption occurs, and improving the safety of Yellowstone visitors.